The implication is the most important connection between propositions in logic and math. We'll deal with equivalence in a later talk. Here's the definition of logical implication. The symbol is a right arrow, and you can read it as implies. So here's a truth table with all four possibilities for the truth and falsity of P and Q laid out. And the third column, we have the truth values of the implication itself. Notice that only in the second row, when P is true and Q is false, is P implies Q false. Otherwise, it's true. What kind of connection does this make between two propositions? In fact, it's a kind of guarantee. The truth, if the proposition P implies Q is true, the truth of P guarantees the truth of Q. So that when that corresponds to the first row, when the implication is true, and if P is true, then Q is true. In the second case, in the case that P is true and Q is false, the implication doesn't act as a guarantee. It doesn't fit the facts. The question is, how do the last two rows figure in this? Well, we have to give it some truth value, and we use something like the legal guarantee, innocent until proven guilty, and say an implication is taken to be true unless it's proven to be false. Let's look at an example. Okay, consider the complex proposition: if there are no clouds in the sky, then it is not raining. With C naming there are clouds in the sky, and R naming it is raining, those are simple propositions. This sentence expresses this logical claim. Not C implies not R. The English sentence expresses more than the logical version. It alludes to a causal relationship between clouds and rain. This is not important here. Let's consider how each row of the truth table relates to this proposition. Consider just the first row. The first row, and think of it in terms of each row corresponding to a different set of possible worlds. In the first row describes those possible worlds in which there are no clouds in the sky and it is not raining. In these worlds, the condition guarantees that there's no rain. Here, the implication is tested and proven true. Consider the second row. The second row describes those worlds in which there are, again, no clouds in the sky, but contrary to the guarantee, it is raining. In these worlds, the condition does not guarantee that there's no rain. Here, the implication is tested and proven false. Consider the third row. The third row describes those worlds in which there are clouds in the sky and it's not raining. After all, cloudy skies don't always rain. But is the implication true or false? The implication is not being tested. P is not true. So we say the implication is true. Remember, the implication is true unless proven false. Consider the fourth row. In the fourth row, the worlds being described are those with cloudy skies, like the third case, but it is raining. After all, cloudy skies do sometimes rain. Is this implication true or false? The implication, again, is not being tested. So we say it is true unless proven false. Let's consider these last two examples in a little bit more concrete detail. If you ask a weather scientist, will it rain? And they reply, if there are no clouds in the sky, then it is not raining. We can then come across and see how to apply this. Suppose there are clouds in the sky and you decide not to go on a picnic and it does not rain. You might be grumpy because you didn't go on a picnic when you could have, but you can't complain. The weather scientist's claim does not apply to this case. Let's say there are clouds in the sky and you decide to go on a picnic, but it does rain. You cannot blame the weather scientist. Their guarantee does not apply to this case. In these cases, we let the weather scientist off the hook. The claim the weather scientists make does not contradict the facts, so we take it to be true.